All right, for section 3, we're looking at side angle side congruence and hypotenuse leg congruence. So let's look at our first two congruence theorems. For side angle side, SAS, this is telling us that if we know one side is congruent to another side in a different triangle, the angle right next to that side is again congruent to the angle right next to it, and a third side, or should I say a second side, okay, third piece of information. But so we have side over here, side, angle, side, being congruent to each other. These have to be the same exact triangle. Okay, well, they have to be exactly the same or have to be congruent. And why is that? Well, if we had two angles, we don't know how big they are, but if we know that they are exactly as big as each other, so the same degree measure, maybe they're both 60 degrees, maybe they're both 23 degrees, whatever it is. Now, angles can go on forever. We don't know necessarily how big they are, but in this case we do, because we have the two sides on the edges of them. So this one only goes out so long and so long. So those green sides are the exact same length. Same thing, the red one here, it's only going to go out so long. That's just as long as this piece. Well, there's only one way to connect this triangle, to kind of put everything together, and that would be right here and right here. Now those have to be the exact same length, okay? And when they're the exact same length, again, because right here and right here are endpoints, they have to be exactly right there, which means that this has to be the same as this, so the two triangles have to be exactly the same. So if you know a side, an angle in between, and the third or a second side, congruent to side angle side, it has to be two congruent triangles. Let's look at hypotenuse leg. This one says in a right triangle. So for hypotenuse leg congruence, I want you to highlight or underline. It's very important that you know this only works for right triangles. If the hypotenuse, remember hypotenuse is like our C value. If we have a right triangle here, we have the two legs, we call them A and B, and the hypotenuse is this length that is across from the right angle, that's our C. So hypotenuse, the C value, and a leg of one triangle, so it doesn't matter, it can be A or B. But if we know the hypotenuse and the leg are congruent to the corresponding leg and hypotenuse of a second triangle, now this second triangle also has to be a right triangle because it has to have a hypotenuse. If we know that the hypotenuse and the leg are congruent, then we can say that they're congruent triangles. Now, there's something kind of special about this case. We'll see in a second that normally side-side angle doesn't always work. So what this is telling us is this side, and the angle right next to it, side-side angle, is congruent to side-side angle. Normally that doesn't work. That doesn't actually tell us if they are congruent. But in this case, this one is very specific because this is a right angle and this is a right angle. We can use our Pythagorean theorem. Remember, that's the a squared plus b squared equals c squared. We can use that to find what this side is. And that's going to be the same as this side. Okay? These two pieces have to be exactly the same as each other because this piece is the same as this piece. This one is the same here. So when we use the Pythagorean theorem, that last piece, the b, or the a, that extra leg, has to come out to be the same exact thing. Okay? So technically, when we're using hypotenuse leg, it's actually more like using side, side, side. So this is a special case of side-side angle that actually works. So, looking at the next couple of pieces here, let's look at what doesn't prove triangles congruent. So things that aren't actual triangle congruencies. And one of them is angle, angle, angle. So usually we've found out that if we know three things about a triangle, we can usually say that the triangles have to be congruent. Well, in this case, if we know that this angle equals this angle, this angle equals this angle, and this angle equals this angle. Okay, all three of them, they're the same exact measure. Okay, A equals P, B equals Q, C equals R. Now you can tell just because they're the same measure that these are not actually congruent triangles. Okay, if we look at it, this one is obviously smaller than this one. Now they kind of look similar in shape. They look like they might be, like one might just be the other one kind of blown up or zoomed in on. And the smaller one might be the bigger one just kind of shrunk down. So technically, yes, angle, angle, angle proves triangles to be what's called similar. Now we won't work with things being similar for another couple units. So it does prove them similar, but it doesn't mean that they're congruent. Okay, similar means something completely different. It'll have to do with ratios and finding out the lengths of sides using similar ratios. But for right now, what you need to know is that angle, angle, angle does not mean that the two triangles are exactly the same. They're not congruent. Another one that doesn't work, side, side, angle. Now remember, this does work if we know that is a right triangle. If it's not a right triangle and we just know the side, side, and angle of one triangle being congruent to the side, side, and angle of another, we can't say that they are congruent, and here's why. In this case, we can see that this angle, angle A, is congruent to angle P. We know that they're the exact same. We know that length AB is the same as length PQ. Okay, that was given. If we look closely though, this length right here from B to C is the same as from Q to R. Check out the two triangles though. This angle is much bigger than this angle. This angle is much smaller than this angle. Okay, so technically, you can kind of see this shadow over here. This could go over here and be the same length, and then this one would have to come out this way to meet it. So technically, if we know an angle and two sides that aren't that don't surround that angle, if we know that they're congruent, we can make two different triangles out of that. But since it's a possibility of two different triangles, we can't say for sure that one triangle is the exact same as the other one. So these don't, the side-side angle does not prove that the two triangles are the same. We can't use SSA to show congruence. So let's look at some examples here. So we just went over two new triangle congruencies. So let's see what how these look. If we look at this picture here, we can see a triangle formed with the points W, T, and V. And we can see a triangle formed with X, Y, and Z. So what information do we need to prove these triangles congruent using angle, side, angle? Well, we have an angle right here, angle V, this side, VT, and if we wanted the angle next to it then, we would need to know that this angle, angle T, would be congruent to something else. Now again, which angle would we necessarily need to use for that one? Well, V right here is the same as Y. Length VT, or this side, is the same as YX. So T here would have to be the same as X over here. So we would say then angle T equals angle X. If we know that information, then we could say the triangles are the same using angle, side, angle. Okay? Let's look at our next one. What information we need to prove these triangles congruent by angle, angle, side? Okay? So angle, angle, side means we'd have two different angles and a side that's not in between them. So it's really important to remember that this side is not in between the two triangles, or the two angles. So we have a side and an angle here. So the other angle we would need then is down here. That way it wouldn't be in between the two angles. Same thing in our other triangle. We have a side and an angle, so we would need the other angle, the one that was not in between them. So we would need to know that angle W equals angle Z. That would be the only way to prove that these two triangles are the same using angle, angle, side. What information would we need to prove these congruent by side, angle, side? Okay, so if we knew two sides and the angle that is in between them. Okay, again, it's really important that it's the angle between the two sides. Well, we have side right here, side and side. We have an angle here and here. So we need a side in both cases that makes the two sides surround the angle. So that would be this side right here. So we'd have side, angle, and side. And in this case, in our other triangle, it would be this side right here. Now you can see that the angle is in between two sides that are equivalent to each other, or congruent to each other. So what information do we need to know? We need to know that side, or the length, from V to W, so here to here, this side, is the same as from Y to Z. So VW equals YZ. And our last piece for this one, write the congruency statement for these triangles. So if we have these two triangles and we want them to be, we want to say that this triangle equals or is congruent to this triangle, again, we just need to make sure we match everything up into its equivalent parts or matching parts. T is kind of across from the longest side there, so T is the same as X in this case. V is the one that has the double soup angle from it, so that would be Y as the second letter. And W is the furthest one, or the one opposite away from the side that we know. Well, that would be Z in this case. It's opposite of that side. So TVW equals, or is congruent to, technically these should have the congruent symbol, is congruent to XYZ. Now, you can say it either way. You can put the little triangle symbol in front and say triangle TVW is congruent to triangle XYZ, or you can just say TVW is congruent to XYZ. The only difference there, the only reason we have kind of a discrepancy between that, triangles get their own little symbol. So we'd say specifically this is triangle TVW and triangle XYZ. Other figures, like if this had 4 sides to it, you would just name off the letters, just name the figures, and they wouldn't have the triangle. So you can simply just say the letters, but many times you'll see it written as the triangle symbol in front of it, saying that these two triangles are congruent to each other. So here's a case of that. You can see that what they're asking for us to do is prove that triangle ABC is congruent to or is equal to triangle DEC. Okay, that's the proof statement here, what we're trying to get at. Okay, so in this case we have a 2-column proof. They tell us that BC equals EC, so BC here equals EC, it's the same length. They tell us that AC equals DC, so A to C, D to C, and we need to prove that these two triangles are the same. So if we look at that then, you always start off with your given statement. So BC equals EC and AC equals DC. The reason, of course, is because that is given information. Now if we look at our figure, we see 2 intersecting lines right here, which means that they form vertical angles. So those angles right there have to be equal to each other. So we would say then that angle BCA equals angle ECD. How do we know that for sure? Well, because they are vertical angles. Vertical angles are always going to be congruent. Or you can say definition of vertical angles. They have to be exactly the same. Vertical angles are congruent. Our last piece then, if we look closely, we have side equal to each other, angle being equal to each other, and a side being equal to each other. So we can say then that ABC equals DEC. I left a little space here so I can show you. If you want, you can put in that triangle symbol. Triangle ABC equals triangle DEC. Oh, smartboard got a little off there. There we go. So triangle ABC equals triangle DEC. How do we know that? Because side, angle, side. We're using our side, angle, side congruence theorem to say that these two triangles that are made right here, they're the exact same triangle. All right, this last piece is pretty long. In the following diagram, Midtown, right here in the middle, is exactly halfway between uptown and downtown. What is the distance between downtown and Lower East Side? How do you know that? Write a few sentences to convince a reader your answer is correct. So normally when we do proofs, we've been doing the two-column proof. Well, here's an example of a paragraph proof. This is what you would have to write to prove everything without using a two-column proof. So let's start through on this. Since Midtown, right here, is exactly halfway between uptown, up here, and downtown, and the distance from uptown to Midtown is the same as the distance from downtown to Midtown. So these distances have to be the exact same because it says it's exactly halfway between them. So that makes sense. That's our first statement. Since we know the distances are the same, and we know that this distance from uptown to midtown is 2.1 kilometers, then downtown is also 2.1 kilometers from midtown. So we would write in 2.1 kilometers is from midtown here to downtown. It has to be. Okay, so those first two sentences just kind of proved or showed that piece there. Okay, the next sentence, the roads that intersect at Midtown form vertical angles that are equal in measure to each other. So this road comes right through Midtown. This road comes right through Midtown. Smartboard's getting kind of off. And we can see then those two roads intersect and make vertical angles here and here. Those angles have to be equal to each other. So I'm going to get rid of the road pieces on there, and we'll just leave the angles. This angle equals this angle. Okay. So, another piece. Uptown and downtown are both intersected by roads that make right angles. So we can see we have a right angle here and a right angle here. And all right angles are equal in measure to each other. We know that all right angles equal 90 degrees, which means all right angles are equal to one another. So it looks like we've got now that green angle, the right angle, a red side, and a blue angle in each of our triangles. They each have angle, side, angle. So moving on to the bottom part of our paragraph proof, the diagram shows two figures that are triangles that have two matching angles and the side between them congruent to each other. Angle, side, angle, congruent to angle, side, angle. That means the two triangles are congruent by ASA, or angle, side, angle. Okay, since the two triangles are congruent, all matching angles and sides are congruent. So any place that I match on these two triangles, they're going to be exactly the same. Okay. Normally when we write it with a two-column proof, that's where we would say CP, CTC. Corresponding parts of congruent triangles are congruent or equivalent. Okay. That's like a quick way to say that sentence. So the distance from downtown to Lower East Side is the same as the distance from uptown to Upper West Side, which is 1.5 kilometers. So this distance has to be the same as this distance because these are two equivalent or congruent triangles, which means that this distance, what they were asking for, has to be the same. It has to be 1.5 kilometers. Now that was kind of long, kind of annoying to write all that stuff down. That's why we normally do the 2-column proofs instead of the paragraph proofs.